Hello everyone, welcome back. Today we're going to take a break from the gun training and we're going to talk about cosmology. Yeah, so in addition to, gun training and all the other stuff that I do, I also like to, follow, I like to study cosmology. When we talk about cosmology, what we're basically talking about is, the planet theory, how planets revolve around stars and that kind of stuff, okay? So what I'm going to be talking about is a theory that, as far as I know, I've developed. I haven't seen anybody else that follows this theory or even believes in it. But the idea here is that it's based on Einstein's theory. Okay, now if you're not familiar with any of that stuff, you're probably going to want to skip this video, go find a gun video or something, because this is going to be extremely boring to you. Okay, but if you are interested in this stuff, if you are already familiar with Einstein's theories, and by the way, we call it, a theory, Einstein's theories, but it's really not a theory. At this point, it is one of the most proven, science fact things that we have. Okay, so it's no longer, Einstein's theories is we just call it that, but it's not theory at this point. It's fact. Okay, it's been proven time and time again. The thing that I'm focusing on is mostly his theory of general relativity. Okay, and that's basically the science of gravity. Okay, and the idea there is basically that large masses, and even small masses, have gravitational fields. Okay, and those gravitational fields basically warp time and space. Okay, time space is a variable in our world. Okay, and what that means is that it changes. Things such as like the mass of planets changes the time and space on and around it. So for example, if you have an atomic clock here on Earth and you have an atomic clock in orbit around the Earth, okay, the speed of the two atomic clocks is going to be going differently because here on Earth, time and space is slowed down just a tiny bit by the Earth's mass. Okay, so and it's not like the clock is actually running slower here on Earth. It's just that the whole space around it, the whole time space environment around it is actually in its own bubble and it's moving slower. So to jump ahead, okay, so basically, large masses slow down time, so the Earth slows down time here on Earth. A larger mass like the Sun would slow down time even more, okay, and then black holes, which are basically these gigantic mass things that we don't really fully understand what they are. We just know that they have a lot of mass and they have so much mass that light can't escape it. And the idea there is that a black hole has so much mass that it slows down time so much that if an object were to fall into the black hole, okay, to the outside observer, we would see the object, going in and then, slowing down and eventually stopping, okay? Now, from the perspective of the object going in, it's just going straight into that black hole. It is just to the outside observer, it seems to be slowing down and stopping because we are moving at, we're basically in a different time universe, so to say. Okay, the object's going through really fast, but to us, it's going through so slow that it looks like it stopped. So, here's the idea. Here's my theory. It's widely accepted by scientists that black holes slow down time, almost to a standstill to the outside observer. Okay, so my theory is that the galaxy, our entire galaxy, in of itself, has its own gravitational field, right? That's kind of what holds it together. Now, if you get, as you get further and further away from, let's say, black holes and suns and all these masses, my idea is that time speeds up, okay? Because since it slows down near masses, it speeds up as you get further away. So my idea is that if you get to a point in space between two galaxies, time is going, to the inside observer now, right? To the person's inside the galaxy, time would be speeding up, okay, if you are at a point between galaxies. And not only is time speeding up, but the whole, the whole space is also being shortened. So my thought is, my opinion is, okay, that as you leave our galaxy and you're heading to a different galaxy, okay, what's happening is the time is speeding up and the space is shortening. Okay, so from our perspective here, it looks like, galaxies are really, really, really far away. Okay, but my thought is that if we were to actually attempt to travel that, okay, and that, by that I mean, get outside of our solar system, and then get outside of our galaxy and start traveling towards another galaxy. My thought is that the time would start speeding up and the space would start shortening up. Okay, and all this stuff's going to sound like utter nonsense to you unless you are somewhat familiar with general relativity. Okay, but those are my thoughts on that. Of course, not proven, and the only way to prove this is you'd have to actually be able to travel outside of our galaxy. Okay, so I can't think of any way to prove this other than being outside of our galaxy and being able to test this. Okay, well, they're my thoughts. Thanks for watching. I'll see you guys next time.